Okay, welcome back pre-algebra to section 5 of chapter 5, solving two-step equations. We are here for day 2. Today we will continue to solve two-step problems, but let's do it with some real-world scenarios. So here we have a real-world situation. So you'll need to take this down. Your family paid $224 to rent a boat. The marina charged $26 per hour plus a fuel fee of $42. So how many hours did your family rent the boat? If you need to pause the video to take that down, please do. We could start by writing a verbal model for this, right? We could say, what's going on here? Well, somebody is paying, a family is paying $26 per hour, right? We can write that as $26 per hour, right? When we see that, we see two different units, dollars and hour, right? Two different units, and what do we call that? That's right, it's a rate. When we have a rate, we are going to end up, let me write this rate slightly differently. Let me do it this way. Put the hour down low, right? Fractions are usually easier to work with when they're in this format, okay? So when we have a rate, we see that the denominator says that we are paying $26 per 1 hour, right? Very good, so it's a unit rate. So if only we knew how many hours they rented the boat, we would multiply by that, right? If it was 1 hour, we could place 1 hour up here, right? And when we do that, let me expand this. Look at this, when we multiply across, the hours would cancel out. Hour over hour is 1, right? So we would have $26. If we were multiplying by 2 hours, the hours would still cancel out, and we would say, oh, $52 for the 2 hours, right? So we're going to multiply this rate by an unknown amount of hours. We could call that X, or we could call that H, right? Because we have the form here, we'll put X, right? X number of hours, okay? So once we know how much they paid based on the number of hours, we would simply add the other term that we were given in the problem, and that's the fuel fee. So we would add $42, and together the rental fee by the hour and the fuel fee, this family paid a total of $224, right? Okay, sometimes these equations are easier to look at when we take away the unit forms. So we could say 26 times H plus the 42 equals 224. And now we look at an equation here that looks very much like the ones we were solving yesterday. What will we undo first? Will we undo this multiplication or the addition? Very good, we're going to undo the addition. Always undo addition and subtraction first, right? So subtract 42 from both sides of the equal sign. And when you do, let's underline it here, right? When we do, what do we have left? On the left side, we have 26H, right? 26 times H equals, what is 224 minus 42? Well, that's 182, right? Very good. And so now we're just simply going to divide both sides by what? Okay, so we'll divide both sides by 26, right? Divide by 26. Very good. And now we have 1H, because 26 over 26 is just 1, right? 1H equals, how many times does 26 go into 182? Okay, so we do the division. Again, the top is being divided by the bottom, right? Top dog goes in the doghouse. And when you do the division, you might need to go over here and do some scratch work. Try to beat me to it. And 7. Very good. So 7 hours is the number of hours that the family paid to rent a boat. Let's try a few other two-step problems. So here we have solving an equation with a variable in the numerator. All right. Okay, so we have a fraction. So we have two operations taking place on the left side of this equation. And one is subtraction, right? And the second one is division. Fraction means division. So if we think about PEMDAS, as we've talked about before, when we don't know what that variable is, we have to undo the operations in reverse PEMDAS order, right? So we will undo any addition or subtraction first. So how can we undo subtracting 11? Very good. We add 11, right? Add 11 to both sides of the equal sign. And draw a clean line. And over here, negative 11 and positive 11 leaves us with 0 there, but we still have x divided by 5, x over 5, plus 0, so we don't need to show that, equals 15. Good. Okay, and now this operation again is division. X divided by 5, so what can we do to both sides? The inverse of dividing is multiplying, so we will multiply by 5. Multiply both sides by 5, and 5 over 5 is 1, right? So 1x is the same as x. X equals 50 plus 25, or 75. Very good. Don't forget, we could take this value and plug it in right here. 75 divided by 5 would give you 15, minus 11 is 4. Yay, we know we have it. Good job. Okay, let's try a couple more and come back and check your work. Okay, so we're going to save the undoing of the division for second. We'll undo the positive 11 by subtracting 11. Negative 11 to both sides, right? And we end up with 2 equals y over 3. And y over 3, what operation again? Very good, that's division, so we will multiply by 3 on both sides of this equal sign. And 3 over 3 is 1, so we have y equaling 6. Very good. And number 4, undo the addition or subtraction. So let's undo the subtraction. Add 3 to both sides. Very good. And we end up with z over 5, which is division, right, equals 7. So what is the inverse of dividing by 5? Very good, multiplying by 5. Multiply both sides by 5. And 5 over 5 is 1. We have 1z equals 7 times 5 is 35. Excellent. If we plug that back in, 35 over 5 is 7, and 7 minus 3 is 4. Okay, this is the trickiest part of a two-step problem. This is a real 7th grade two-step problem because we have a negative in the coefficient. So it's a very negative year, as you know. Let's start by, there's 2 ways we could do this, but we're going to try to use the same process we've been using. So we look and say, is there any addition and subtraction? And there is. There's adding 5. So let's subtract 5 from both sides of the equal sign. Remember, both sides of the equation. Okay, so when we do that, we're left with positive 5 minus 5 is 0, right? But we still have this. Negative 6x plus 0 is negative 6x. There it is. Equals, what is 23 minus 5? And that, you're right, is 18. Okay? And so now we have what operation still remaining? Multiplication. So we have negative 6 times x. So what's the inverse of multiplying? Very good. We're going to divide by negative 6. If we divide by negative 6 on both sides of this equation, look at negative 6 over negative 6 is positive 1, right? We have 1x. Yay. Equals, what is 18 divided by negative 6? Good job. Negative 3. So x equals negative 3. If we substitute that back in, negative 6 times negative 3 is positive 18. 18 plus 5 is 23. Excellent. Okay, this is a really tricky one because we're subtracting a. So we could also say that we are adding a negative a, right? Negative 1a. Okay, so the first thing that we are going to try to do is move this 16 out of here. So what's the inverse of 16? That's right, negative 16. So we're actually subtracting 16 from both sides. Good job. Okay, and sometimes people see that subtraction and they think, oh, I got to add 16. But if we think about that, 16 plus 16 would not move 16 away from a, would it? But 16 minus 16 eliminates it from this side of the equation. And we're just left with negative a, right? Equals, what is 6 minus 16? Good job, negative 10. All right, and now how do we get this negative away? Well, do you remember the coefficient? What number is there when you don't see a number in front of the variable? That's right, it's 1. Okay, so this is really negative 1 times a. So we can undo this multiplication with division. We can divide by negative 1. And when we have negative 1 over negative 1, we end up with a positive 1, don't we? We'll also have to divide the left side of the equation by negative 1. Okay? And so now we have 1a, nicely positive, equals, what is negative divided by a negative? You got it, a positive, positive 10. So when we stick that back into the original equation, we have 6 equals 16 minus 10. And that is true. 6 equals 16 minus 10. There you go. Have fun. Do your best. Be sure to check your work. These can be a little tricky with those negative variables.